Hello everyone, here's the notes for the rest of lesson 3. So let's talk about inverse properties. So basically, let's say if we have in a logarithm, so we have log base b. If we have an exponential with the same base, what happens is, know that logarithms and exponentials are inverses. And remember, what does inverses do to each other? They cancel each other out. So if a log with a base b and an exponential with a base b, so meaning that the bases are exactly the same, then what happens is they cancel each other out. So we have equals x. And this is the same if we did it the other way. So we have base b of an exponential, and it's raised to the log base b of x power. Once again, these cancel out because they are inverses. Now, basically, in order for log and exponential to cancel, the bases must be the same. So the bases must be the same in order to cancel. Okay, let's go ahead. We are going to apply some of this information to a couple of problems. So let's look at those problems here. Okay, so we're going to simplify / evaluate the expression. So first, example 5a, we have 10 to the log of 4. Now, you may see this log and say, well, I don't see a base. What is that? Well, remember we talked about two particular type of logs. We talked about the common log and the natural log. Remember, a natural log has a base of e with the log, but common log has a base of 10. So anytime we don't see that base, we can assume that it is 10. So we have 10 to the log base 10 of 4 power. So with our bases, they are exactly the same. They're both 10s, so they cancel each other. So what all is left is the 4. Okay, let's get B. So we have log base 5 of 25 to the x. Now notice, our base of the log is 5, but the base of the exponential is 25. They're not the same, so we can't cancel. Now, what we're actually going to do is use some algebra to manipulate this expression. What we're going to do so we can cancel is make the base of the exponential the same as the log. Now, I can't just magically change 25 into 5, okay? So we have to think, well, how can I change 25 into 5 but still make it equivalent? Well, we know that 5 squared is 25. So all I did was rewrite 25 as 5 squared. Now, don't forget that the 25 has an exponent of x, so I need to keep that there. Now that the base of my log and the base of the exponential are the same, they cancel out. And now all I'm left with is 2x. Okay, go ahead and pause the video and try C and D. Okay, let's see what you guys got. So on C, notice that basically the base of the exponential, base of the log are exactly the same. Because they are the same, they can cancel out, and all we're left with is x. For D, notice that the base of the log and the base of the exponential are not the same. So just like we did with B, we're going to manipulate this so the base of the log and the base of the exponential are the same. So I'm going to make them both 2's, but remember, I can't magically change 64 into 2. So what I need to do here is I'm going to change the base, but then I need to raise it to a power. So this is going to give us 6. So 2 to the 6 gives us 64 here, okay? And then don't forget the x. Now that the bases are exactly the same, they will cancel, and all we're left with is 6x. That would be our answer there. Okay, so now our last thing we're going to talk about in lesson 3 is finding the inverse of a function. Now, we have talked about this. We did this in our last unit. We are now doing it with exponentials and logs. Now, remember the steps. First step is to switch x and y. So anytime we are finding the inverse of the function, we always switch x and y. So now I'm going to have x equals 6 to the y. Then from there, we are going to solve for y. Now in this case, y is actually all by itself, or the base really, so I don't need to move anything over. How we're going to solve for y is actually rewrite in log form. So that's why it was so important for us to know how to switch from log to exponential form and vice versa. Now remember, with our log form, don't forget the acronym BOY, right? So we talked about how that's the base, we go to the outer, and then we go to the inner. So remember, base is for exponential wise is always the one with the exponent. So here, when we write it, we have log base 6. Now from there, we go to the outer. So our outer here is x. So we have log base 6 of x, and then we go to the inner, which is equal to y. Okay. And then from here, we want to use our, well, from here, we can just leave our answer as this. Now, you can write your answer in inverse function notation. We are just going to leave it here since we just have a y equals. So this would be our answer. Okay, let's look at B then. We have y equals natural log of x plus 3. Okay, so we do the same step. So very first step is we switch x and y. So I actually have x equals natural log of y plus 3. Now, you will notice that this y plus 3 is in parentheses. So when we solve, I can't just subtract 3 to the other side. This y plus 3 is with the natural log. So in this case, in order to solve for y, I'm actually going to have to rewrite this in exponential form. So just like we did in the last one, we are going to use boy to help us out. Okay. Now, this is where we have to be careful, right? Because remember, natural log is one of our special type of logs. So we have to think, well, what's the inverse of natural log? Well, the inverse of natural log is the natural base e. So natural log is always inverse of e and vice versa. So we start with that, so that we can say is our base. Then we go to the outer, which is going to be x here. Then we go to the inner, so y plus 3. Now, to make sure, remember, we're trying to solve for y. That's always the goal when we're finding the inverse. Now, notice y is not by itself. What I'm going to have to do lastly is to subtract 3 from both sides. So then that means I'm going to have e to the x minus 3 equals y. And that's going to be my inverse. Okay. Okay, let's try another one. Okay, we have y equals 3 to the x plus 2. Once again, very first step is to switch our x and y. So I have x equals 3 to the y plus 2. Okay, now know how this is a little bit different from the last one. This plus 2 is not in parentheses. So this one, before we actually switch forms, I am actually have to subtract 2 from both sides. So I have x minus 2 equals 3 to the y. Now I go ahead and do my second step of rewriting in the other form, or another way of saying it is you're solving for y, right? So in this case, because it is already in exponential form, we rewrite in log form. And remember, we're going to use our boy here. So we start with the base, okay? So we have log base 3. Then we go to the outer. Now notice the outer is not just x, it's x minus 2. So to represent that the x minus 2 is together, I am going to have to put that in parentheses. Then I go into the inner, which is y. Now this is where you're going to have to be careful. When basically when you have this value, like we're going to see with our d when it's on the outside, versus when we have it inside parentheses, okay? So let's maybe look at our example D, and then we're going to kind of compare it to what we have been doing. So example 1D, First, we always switch x and y. That's something we never waver from. Okay, second step is to solve. Now, when we are doing this, notice that in this case, just like in the last example C, that I am not going to change forms yet. Instead, I need to get the base by itself, okay? So notice that it's only the y, not y minus 1, is in parentheses. So I'm actually going to have to add 1 first. And I have x plus 1 equals log base 2 of y. Now I go ahead and rewrite. So know how this is a little bit different from our b. Our b, the x plus 3 was in parentheses, so I couldn't subtract the 3 because the 3 was with the x. It belongs to the natural log. But if the number is not inside parentheses, like our C and our D here, then basically we have to move it over first before rewriting it in the other form. So here I need to rewrite in exponential form. And so notice that I do have log base 2. So notice that my base is actually 2. That's what's going to be the base of my exponential. So I'm going to go to base to the outer. So that's going to be my x plus 1. So that represents the exponential. And then I go to the inner, which is y. Notice that on all of these, I have y equals, y equals. Okay, y plus 3 equals, y equals. We always want y on the other side because that's what we're solving for when we are doing these inverse functions. We're solving for y. So just be careful with a lot of these problems. It is going to get a little tricky knowing when to move something over before rewriting versus moving maybe something over after rewriting. Okay, we're going to try one more example. Okay. So once again, very first step, we switch. So I have x equals 4 to the y minus 1. Now notice this minus 1, unlike our c, notice that for c, plus 2 is out here. It is not part of the exponent. Notice that for this example, part e, that the minus 1 is part of the exponent. So here, I cannot move the 1 over because it's part of the exponent. Instead, I go directly to my second step of rewriting in log form. So as stated, this is where you're going to have to be careful of when do I move something before rewriting versus moving something after I rewrite. So when we rewrite, remember using boy, I start with my base. My base is 4, so I have log base 4. I go to the outer, which is x, and then equals 2, and then I go to the y minus 1. Now here, because my y is not isolated, I do need to add that over next. And then my final answer is going to be log base 4 of x plus 1. Now this x plus 1 is not in parentheses because really what would be in parentheses is the x, not the plus 1. Think of this as like a k value when we kind of graph. Okay, so that is basically how to find inverses. If you have additional questions, please let me know.